So, Miriam, quickly, I need hydrocarbons, okay, and those hydrocarbons, they are compound consisting of hydrogen and carbon only. Then we have organic chemistry in general. Organic chemistry, they are just compound which are abundant in nature, mostly consist of hydrogen, carbon, and other elements like bromine, chlorine, and other constituents. Okay, now under the organic chemistry, Neomadoki homologous series. Okay, the homologous series is just a pattern. Okay, those organic compound that follow a specific pattern. Okay, so now we are going to pick one by one. There are many. Okay, so we are going to pick them one by one and try to discuss their nomenclature. Okay, how to name them. The first one, we have alkanes, we have alkene. Okay, take note of the spelling. 3, we have alkanol. Okay, 4, we have alkanal. 5, we have amines. 6, we have amides. 7, we have alkanoic. Alkanoic, and there are so many. Okay, we have different protein also, so there are so many. So now each of these have their own compounds. Okay, look at this as each of these, they are what homologous series, and element under alkane share similar chemical and almost similar physical properties. Okay, they tend to change down the group or up the group. Okay, now you have the idea of this already. These are all homologous series. There are still more. Okay, these are all homologous series. Now you need to know each of the carbon, depending on the carbon atom, the number of carbon atom they have will determine the name. Okay, now you need to know this from 1 to 10. Maintain, that is 1 carbon. Okay, ethane, that is 2 carbon. Okay, we have butane, that is what, 3 carbon. We have propane, okay, 4 carbon. We have no, propane, sorry, propane is 3 carbon. Then butane is 4 carbon. Then pentane 5, hexane 6, heptane 7, octane 8, nonane 9, decane 10. Okay, so I believe you should have idea of this already. 1 to 10. Okay, I think they are up to 12 or even more. Okay, but I think 1 to 10 is the most important ones you need to know. So depending on number of carbon in the compound will determine the naming. So 2 things that will determine the naming: you first need to identify the homologous family. Now, after identifying the homologous family, you now identify the number of carbon atom in the primary or the parent chain. The parent chain in an organic compound is the longest chain, while the others serve as the substituent. Okay, now this is it and this is it. You need to know these two to even think of naming. Okay, now let's pick alkane for example. take note of the naming, alkane. Now, before we move on, let me quickly explain. We have talked about homologous series, we've talked about hydrocarbon. Each of these compound, okay, let's say the homologous series or hydrocarbon as the case may be, okay, homologous series, they are still hydrocarbon. It's just that it's just trying to explain that this particular family of hydrocarbon share a specific formula or a specific property between the families, or whether physical or chemical. Now, hydrocarbon or organic chemistry can be divided into saturated, okay, hydrocarbon into what? Saturated and unsaturated. Okay, now the saturated are those that contain single bond, the carbon to carbon bonding, okay, is what? Single bond. Then those that contain more than single bond, double and triple bond, okay, they are all known as what? Unsaturated hydrocarbon. Okay, so now before we enter into the naming, let me first explain quickly the bonding between carbon atom. The bonding that exists between carbon atom is called covalent bond. Okay, if you understand the principle of covalent bond, you carbon, hydrogen, helium, lithium, beryllium, boron, carbon is 6. Okay, that means in the external orbital, it has 6 outside, or it has 4 outside. We already have 2 here, then 3, okay, it has 4 outside. So now this external requires what? 8 for it to be balanced. So carbon is highly unstable. Okay, now for carbon to be stable, it now bond with what? Hydrogen. Hydrogen is 1. That is the first element. Hydrogen for the middle or the first octet, it requires 2. So hydrogen also need 1. So now if hydrogen should donate 1 to carbon and carbon donate 1 to hydrogen, they join their they join their atoms together and bond together. They become what? Carbon becomes stable. This carbon is still not stable. Hydrogen becomes stable. It has to bond with another hydrogen. Okay, then bond with another hydrogen again, H, and here it will also bond with another hydrogen, H. Now by the time you count it, 1, 2, 3, 4, 5, 6, 7, 8, carbon is now stable. So now how many carbon will require what? 1 carbon will require like what? 4 hydrogen on a single bond. You remember, this is single bonding. On a single bonding, 1 carbon requires what? 4 hydrogen for it to be stable. Okay, so this one is just by the way. I just try to explain the concept of bonding and why carbon has to bond, okay, for it to be stable. And hydrogen is readily available. Hydrogen is also unstable. Okay, so it is easier. Carbon is highly available, is readily available also on the earth crust. So carbon is always found naturally with impurities like hydrogen, because it requires it to be what? To be stable. So after understanding this bonding, okay, single bond. If it's for double bond, if we are talking about double bond cannot exist between carbon, okay, cannot exist between carbon and hydrogen, because hydrogen requires just 1. By the time you want to bond double, that means hydrogen has to contribute 2, which it doesn't have. So now double bond exists between carbon to carbon or carbon to oxygen, because oxygen requires 2. The valency of oxygen is -2, so it requires 2. You understand? So either carbon to carbon double bond. Now for the case of double bond, we have it this way. So this carbon will donate 2, this carbon will donate 2. You understand? So 2 2, so it will remain what? After donating 2, it will remain 1 2 1 2. So this is hydrogen again, hydrogen coming to balance up. Even after donating double bond, it's still not balanced, so hydrogen will fill the rest. So we require 2 for double bond to exist for a saturated hydrocarbon. And I told you that saturated hydrocarbon are those hydrocarbons that have double bond or triple bond. We require at least 2 carbon atoms to form the double bond. Then how many hydrogen? 4 hydrogen. Hydrogen 1, hydrogen 2, hydrogen 3, hydrogen 4. Okay, so you can see. So likewise, triple bond. This is not the naming that I wanted to name yet. This is just a general overview of the bonding that exists between in carbon atom and why it is necessary to bond. Now I explain again. It is necessary to bond for carbon to be stable. Okay, carbon can easily form a covalent bond. This is covalent bond, not ionic. Okay, carbon can easily form covalent bond between hydrogen and what? Carbon atom. In a saturated hydrocarbon, it requires double bond. So the less hydrogen, the number of hydrogen required to make the carbon atom stable is reduced. Why the number of carbon atom is increased? Because there must be a covalent bond between, okay, the carbon to carbon, covalent double bond between the carbon to carbon element. Okay, now let's start our naming properly now. After getting this background, alkane. Okay, now alkane is saturated hydrocarbon. Sorry, I hope I don't even make mistake in the first one. I say saturated single bond, unsaturated double bond. If I've made any mistake anywhere, just correct it yourself. You understand? So alkane, alkane is the first of the series. Okay, and remember, this is the what? This is what? The family name. Then you use this to get the naming of the compound. This is the family name. This is the family name alkane, the first family and the most simplest. Okay, it is always very unreactive when compared to the saturated hydrocarbon. Okay, because of what? The lack of what? Double or triple bond in its atom. Okay, now alkane, the first element of the alkane, remember the naming alkane, remember the ane. Okay, ane is different from ene. Okay, so now the first element, for the first element with 1 carbon, we have C H H H H. What we have here is what I just represented here. So the first element requires 1 carbon to what? 4 hydrogen. This is called methane. Remember, it's single bond. So now if I'm bonding singly, I need to what? Keep on balancing till the element is stable. By the time you notice, you require 4 hydrogen to balance 1 carbon. 4 hydrogen to balance a single carbon. Is there another way also, okay, as part of the property of homologous series, they have a general formula. For the alkane family is what? CnH2n plus 2. If you want to use the formula to get this, maintain, if you have to form the formula for maintain is what? 1. That means carbon is 1, N is 1, C1, abi, H2n, remember, H2n, 2 multiplied by 1 plus what? 2. Cn, H2n plus 2. Okay, C1 is same thing as C. H2, 2 times 1, H2 plus 2, which will still give us what? CH4. So either way, you can use the formula to get this. Okay, after using the formula to get this, then you can add, this is called the what? The structural formula. It's the same thing as drawing this way, but in exam case, this one is just to open the bonding for you to easily get an in-depth understanding of this. Okay, but if they ask you to draw the structural formula, this is what you should draw for them. Okay, now for number 2, which is what? Ethane. All of them, they are under this alkane family, under this homologous alkane. Okay, ethane. I know that what? Ethane is what? If I'm to draw the what? Write the formula and draw the structure. Ethane is what? Ethane is 2. I should know that. All this one should be on in your head. Ethane is 2. What does it mean? It means that what? It has to be what? 2 carbon. Whatever I do, and I should know that what? It is what? Saturated. Okay, since it's saturated, that means a single bond. So there must not be anywhere where we have a triple bond existing or single or double bond existing. So if I know that, I can start forming my formula. I can start to use the structure. I can start to use the formula. In this place, we use the structure to get this, and use this. We also use this to get this. Okay. Now this time I want to use the formula first. Cn H2n plus 2 is the formula for just alkane. Okay. Now when I come here, I say okay, N in this case, N is 2. Okay, because I want to form ethane. If I want to form propane, N is 3. Okay, then I now say what? C2 H2 2n, that is 2 plus 2, which will give me what? C2 H2 times 2, that is 4, plus 2 H6. So in alkane, it requires what? 2 carbon to form ethane. 2 carbon require what? 6 hydrogen. So we have this C. Remember, it's single bond. Don't double it. Don't double it. If you are doubling it, you are forming this. Okay, single bond. After you have done this, then require 6 hydrogen. Okay, H. Okay, you might want to ask, how did I know the positioning? Each carbon atom, take this as a rule. Okay, if you understood this very well, you understand this rule that I'm trying to say. Take this as a rule. Each carbon atom must require a bonding from minimum 4. 1, 2, 3, 4 for it to be balanced. 1, 2, 3, 4 for it to be balanced. So now this is what? C2H6. Count the height. 1, 2, 3, 1, 2, 3, H6. So that is alkane. So I'll be going for work now. Okay, listen to this and tell me if you have any question. If you don't have any question, I have some quick exercise for you, and let me know if this is too simple so that I can just quickly run to the advanced topic.